Hey everybody, time for our fourth and final solving variable equation strategy. It is called the inverse operation strategy. Go ahead and turn to your next free page in your math notebook. Make this your title. And when you've done that, close it up and give me your concentration until we get to we do. So we've looked at three strategies so far for solving an equation with a variable. If I were just to make up a quick equation like maybe 2x equals, I don't know, 51. Make up something like that. So the first strategy we learned was called common sense. You may be able to look at that and just tell what the answer is. That was all the common sense strategy was just kind of step back and use common sense to see if you can figure out what x is. In this case, you may be able to, you may not. Our second strategy was called the visual strategy. And in that one, we wrote down like this, and we kind of put each side of the equation in a box or in a bucket or something and said, okay, this side has 2x's, this side has 51. And that, if those are going to be the same amount, using that tool sometimes helps me figure out like, oh, okay, what does each of those x's have to be? I would have to take that 51 and divide it in half, and each x would be 25 and a half, like that. So that was our second strategy, just sort of the visual sometimes helps you make the quick sense of it when common sense doesn't apply or, isn't useful. And then we third learned the guess and check strategy. Guess and check is kind of hard to do when you already know the answer, like I just did, but just to pretend I would just guess, learn and say, oh, I know that, well, I know if x equals 25, 2 times 25 is 50. That's close, but it's too low. If x is 26, that would give me 52. That's too high. So then I might try something in between, like 25 and a half, and get it. So that's the strategies we used so far. And I have one strategy left to teach you. It is a very important one because first, there are times guess and check you'll never be able to guess the right answer. It could be a very complicated decimal or a complicated fraction or something. It'd be tough. The visual strategy starts to get really bad if there's a huge coefficient. If I had like 103x in the equation, you wouldn't want to have to like draw 103 x's. So there's times these strategies can let you down. And this last one's going to work every time. And it's also going to be the one your future math teachers use the most. So I want to make it real clear for you today. So it's called the inverse operation strategy. And if I were to apply it to the same equation we just worked on, here's how it works. I'm going to do one quick example here and then a lot of examples on the next one. So here's what I do here. I say I'm going to first take my equation and split it into its two expressions so that the 2x expression's on its own side and the 51 expression's on its own side. And I kind of like run this thing down the middle just to keep myself clear. So I look at my variable and say, what's happening to my variable in this equation? So I look at my variable and say, what's happening to it? So in this case, it's being multiplied by 2. So in the inverse operation strategy, I'm going to do the inverse of multiplying by 2, which is dividing by 2. So x is being multiplied by 2, so I'm going to divide this whole expression by 2. And that's going to leave me with just x. Let me explain why. If you think about this, I've got some unknown value x. I multiply it by 2. Then I divide it by 2. These are going to cancel each other out. They're going to like undo each other, and I'll just be left with nothing left but x. So this side, if I multiply x by 2, then divide it by 2, nothing's left on this side except just x, because I multiply by 2, then divide it by 2. The only catch is, to get a right answer here, if I divide this side of the equation by 2, then I also divide this side of the equation by 2. And if I do that, 51 divided by 2 is going to give me that 25 and a half answer we already found. So that's how the strategy works. I look at the variable, I see what's happening to it, I do the inverse of that, and then I'll have nothing left but the answer, and I just have to do it on both sides. Let me run through an example with every possible operation on this page. So looking at these four, probably all of these are ones you could do with the common sense strategy. And that's important because I want you to look at these and say, okay, I know what the answer is going to be, but then let me see how this strategy gives it to me. So let's start on this first one here. First one says x plus 6 equals 25. You can stop for a moment and think and figure out the answer with common sense already, I know. But here's how I apply the strategy. So again, I break up my equation into two expressions. I look at the variable, and I look at what's happening to the variable. In this case, I'm adding 6 in the equation. So I'm going to do the inverse of adding 6, which is subtracting 6 from that expression. Because if you had some number and you added 6 to it, and you took 6 away from it, these cancel out, and you're left with nothing but that number. So x plus 6 minus 6 leaves me just x and nothing else on this side of the equation. So the only catch is I have to do that on both sides. So if I subtract 6 on this side, I subtract 6 on this side, and then 25 minus 6 is 19. And that's it. That's my answer, x equals 19. Just to be sure, I can go back and check it, right? If x equals 19, then if I substitute 19 back into my original equation for x, then 19 plus 6 is 25. Yay! So it's right. Okay, let's do another one. So in this one, different operation. So here we added, this one we're subtracting. So again, split my equation. Look at my variable. What's happening to my variable in this equation? Well, it has 8 being subtracted from it. The inverse operation, the inverse of subtracting 8 is adding 8. And if I add 8 on this side, then I get y minus 8 plus 8. And those really kind of cancel each other out. And I'm left with nothing but y on this side. 50 plus 8 on this side leaves me 58. So I get y equals 58. Let's make sure. Go back to my original equation. If y was 58, then 58 minus 8 is 50. And it works. Yay. So that's an addition example and a subtraction example. Let's do a multiplication example. All the same process, it just matters what the operation is. So split my two expressions. I'm going to look at my variable here. Well, first, before I even do it, you can figure out the answer to this one, right? The common sense strategy applies here. So go ahead and do that. And then again, I ask, okay, what's happening to my variable? In this case, it's being multiplied by 6. So the inverse of multiplying by 6 is dividing by 6. Because if I take that number, I multiply it by 6, then I divide it by 6. These cancel each other out. They undo each other, and I would only have a left on this side of the equation. The only catch to doing that is if I divide that side by 6, I've got to divide this side by 6 too. And 66 divided by 6 is 11. You probably figured that out with your common sense that that's it. But I can check. If a were 11, 6 times 11 would indeed be 66. Okay. Last one. This one looks the scariest, but it's no harder than the others. So I'm going to look at this one. D divided by 4 equals 20. Look, what's happening to my variable? It's being divided by 4. The inverse operation of dividing by 4 is multiplying by 4. Because if I had some number, I divided it by 4, then I multiplied it by 4. Those would undo each other. And I would left with just D on this side. I'm going to multiply this by 4. I got to multiply this by 4. And 20 times 4 is 80. Let's check and be sure. If I go back and use substitution, And if D were 80, then this expression would say, or equation would say 80 divided by 4 is 20, which it is. All right, let's try 4 in your notebook. So go ahead and pause and write these examples down. Same thing, we're just going to go through one of each type of operation to hopefully make you feel a bit more comfortable with it. Go ahead, this is the inverse operation strategy. And here we go. Again, on we do, you're welcome to work ahead of me, you're welcome to work with me, or you're welcome to work behind me. So looking at this one, 6.5 plus a equals 16 6/10. Let's apply the inverse operation strategy. So split up your expressions. Say, all right, what's happening to my a? What's happening to my variable? Well, 6.5 is being added to it. The inverse of that is subtracting 6.5, because a plus 6.5 minus 6.5, those just undo each other, and I'll just be left with a over here. But to get the right answer, I've got to also subtract 6.5 here. And I'm going to get 1/10 and 10. 10 and 1/10 is a. And go back and double check and make sure you're right. I always like to do that last. Say, okay, if a were 10 and 1/10, would I get the right answer? I would. All right, next one, subtraction. Same thing, split your things, split your expressions. Look at your variable, what's happening to it? Well, 15 is being subtracted from it. The inverse operation of minus 15 is plus 15, because some number minus 15, then plus 15, you're just left right back with that starting number you had. Have to do it here too. 10 plus 15 is 25. Let's check and make sure that's right. If a was 25, then this would say 25 minus 15 is 10, which it is. Okay, 2 to go. Hang in there, almost there. Hopefully you're getting the hang of this. So this one, 2x equals 9. What's happening to my variable? It's being multiplied by 2. The inverse operation of multiplying by 2 is dividing by 2, because x times 2 divided by 2, those undo each other, and I'm left just with the x. Have to divide the other side by 2 as well. 9 divided by 2 is 4.5. Go back and check. 2 times 4.5 is 9. Yes, it is. Last one. This is the scary looking one, but it's not different than the others. We added, we subtracted, we multiplied. The whole process still works with dividing as well. Looking at my variable here, after I split my equation, here c is being divided by 10. The inverse of that is to multiply by 10, because c divided by 10 times 10, those undo each other, cancel out, and I'm just left with c times 10 on the other side as well, and c equals 70. Going back to double check, make sure I got it. If c was 70, then this would say 70 divided by 10 is 7, which it is. So that's the inverse operation strategy. It's a biggie. It's important. As equations get more complicated, this is going to be the one you can count on the most, so it's going to be important that you really work on it and do a good job. I hope this helped make sense of it. If not, hey, give it another try. Watch again to make sure you really master this strategy before class, and I'll see you there.